Solving recurrence relation through substitution method. Suppose we have this recurrence relation, so how we are going to write it? We are going to write Tn is equals to Tn minus 2 plus n square, and further we can write Tn minus 4 plus n minus 2 whole square plus n square. So this we can suppose as n minus 2 2 into 1. We can suppose this, we can suppose 4 2 into 2, like that. So next will be T n minus 6 plus n minus 4 whole square plus n minus 2 whole square plus n square. So this 6 we can suppose 2 into 3. So we can write like this: T n minus 2 into 3 plus, same thing we can write like this, n minus 2 into 2 whole square, 2 into 2 whole square plus n minus 2 into 1 whole square plus, for n we can write n minus 2 into 0 whole square. We can suppose this. So if we do this k time, then if it go up to k time, then what it will be: T n minus 2 into k plus T n minus, because this is 2 into 3 and this is 2 into 2, so this is 2k, so we can suppose this 2k minus 2, because here 2 into 3, here 2 into 2, so we can decrease 1 2 from this. So if this is 2k, so this will be 2k minus 2. So we can write like this: 2k minus 2 whole square plus, this will be n minus 2k minus 4 whole square, like that, and at the end we will get n minus 0 whole square, like that we will get. So we can suppose n minus 2k is equals to 0, n minus 2k is equals to 0, then n is equals to 2k, or we can say k is equals to n by 2. K is equals to n by 2. So we simply put here k is equals to n by 2. So because n minus 2k is, we are supposing 0, so this will be 0. This will be t 0 plus n minus 2k, or again this will be 0, n minus 2k minus 2, only minus 2 will left, so minus 2 whole square, or we can say simply 2 square, because minus square will be always plus only, because this is square. So this will be n minus 2k, again 0, so 0 minus 4 minus 4 minus 4 square always will be positive. So we can write like this: at the end what we are getting, plus n square. So we can simply say 0 plus 2 square plus 4 square plus 6 square, like that, and instead of n what we can write, 2k. Instead of n what we can write, 2k from here, so plus 2k square. So we can say like this: 0 plus, if we are taking 2 square as common from all these, so what we will get here, 1 square plus 2 square plus 3 square, like that, at the end plus k square we will get. So we can simply say this is the 1 square, 2 square, 3 square, and like that at the end k square. This is the natural number square, this is the natural number square, so this will be k plus 1 2k plus 1 upon 6. So if we multiply with all of them, so what we will get here, kq. What we will get here, kq. So what is the k value? We can simply say k is equals to n by 2. So instead of k, what we will write here, n by 2 cube. So we can simply say this is order of n cube. By putting the values with the help of substitution method, we find out the complexity of that recurrence relation is order of n cube.